presentation كان ما فيها، فلازم نغطي البارتس اللي موجود اللي ما غطيناه بالميتينج فور. for this reason بكرة إن شاء الله وقت المعمل ما راح نحل الاكتيفيتيز اللي حق ميتينج 11، راح نغطي فيها الميسنج بارت اللي ما غطيناه بالميتينج 4 اللي هو الداتا ستراكشر الستاك والكيو. طيب ما راح يكون في تغيير في الوقت ولا تغيير في الرابط، نفس الرابط نفس الوقت، لكن بدل ما نتكلم بالاكتيفيتي 11 نحل فيها اكتيفيتيز، راح ناخذ فيها لكتشر نكمل فيها الميسنج بارت من الميتينج 4. Three more minutes إن شاء الله، على 4:05 نبدأ إن شاء الله. We'll talk about recursions. Recursions, the main idea behind it is similar to iterations اللي احنا عادة we usually do it with a loop, but here it has some special properties. Okay. They give you an example. Let's assume if you have a directory and you would like to go to subfile, and that sometimes you may have a directory and subdirectory and so on. So you need to go over it until the end. Okay. This is one of the example is the H tree. What is the H trees? You'll see here in the pictures. We will do something look like it at the end, but with a triangle. So if you're having an edge at the end of each point, here and here and here, and 4 points, you're going to create another edge. Again, at the end, let me just use. Okay, so at the end here, 1, 2, 3, 4, we have 4 ends. At each end, you will repeat the same process of creating an edge. Again here, you will have 4 ends for this one. You will repeat creating an edge at the end of each of those for the first one, for the second one, third one, and fourth one. So this is the 0, the one you're creating edge, one edge at each end. The second step, you're going to create again 4 edge at the end of all the edges you have it. Okay, so this is the final, or let's say the third step picture we're going to get here, and this is use recursions as what we see an example at the end. Okay. The objectives, we will talk about the recursions, how it's different than a loop, what's the relationships between it and the iterations, how we get the direction. We will talk about example of file and so on. Okay. So first, the repetitive algorithms that we already used again and again since 105 is the iterations, which is using a loop. A while or a for example. Now we will use something called the recursions. And what's the recursions? It's an algorithm call itself. So let's say this is the main things here. It's an algorithms call itself. Usually we write recursive algorithms inside the methods that call itself several times for certain, and it's going to terminate it at some point. So the main behavior, first, it's going to call itself. Second, it is going to call itself several times as like it's a small part of a problem, but it's the similar problem. And it's going to terminate it at some point. So you need to decide when it's going to terminate the process. This is what I just said. So usually a recursive has those characteristics. The first characteristic, it has to have one or more base cases. إيش هو البase cases? What is the base cases? That is gonna to either terminated the process, so it's not going to call itself anymore. It is going to symbol cases, or the cases that is going to tell you how you're going to call itself again and again. Every recursive call reduces the original problem. This is the main point or objective in a recursive. We would like to reduce the problem. So we're going to bring it closer to baseline until it's become that case, the baseline اللي هي simplest أسهل أو أبسط cases we can go over it. Sometimes it's equal to 0, equal to 1, sometimes something else depending on the problem. The part we're going to divide the recursive into it, it's almost the same as the original problem. So we don't divide the problem to different problems, sub-problems. Sub-problems similar to the original problem. This is important point. So it's not a new idea. It's similar to original problem, but it has a smaller size. Okay. A famous example of a recursive is a factorial. What is a factorial? The factorials, when you have, when we ask to do factorials of 5, how much is a factorial of 5? 5 multiplied by 4, multiplied by 3, by 2, by 1, and the result is going to be 20, sorry. How we can create this one? We said in factorial, the first things to create a baseline, they're going to give you a baseline, but for yourself to figure it out. If I asking you, what's the baseline? What is going to this is stop the simplest things, it is going to be 1. So 1 is going to be 1 when n is equal to 0. So the factorials of 0 is going to be 1. Here, factorial of 0 is going to be 1. So this is the first case. What's the second case, or the second base case? Is that all otherwise things. Whenever n is bigger than 1, so all other cases, it is going to be n, then it's multiplied by n minus 1, n multiplied by 2, n minus 3, n minus 4, and so on until we reach 1. We're going to stop at 1 here because 0 is going to be included on the other cases. So this case have all the number from n till 1, and this case have 0. Okay. So here we see, if we have a factorial of 5, if we're dividing it to writing the factorials with the idea of recursive to see how it's calling itself. So we're having first till 5. Then it's going to be multiplied and it's going to call the same function again. So the factorial is going to call the same function again, but now it's going to be n minus 1. So it's going to be 4. Then we will have the 4 multiplied by n minus 1, so it's going to be 3, and so on and so forth. When is going to stop? When you have the factorials of 0. So it's going to be 1. And the result is going to be 120. How can we write this on code? So here we're using iteratives, or we're using a recursive factorials in this example. We're using, in this example, an iterative or a recursive. You see the example, guys? So in this example, are we using an iterative factorial or a recursive factorial? Yes, we are using, thank you, Ahmed, an iterative factorial. Because we're having what? We're having a loop. So now let's say if you're having an example, we're having n, and you would like to calculate the factorial for it. We're starting with initializing the factorial with 1. And this is one of the things I need you to remember, guys. If you are calculating the average, the sum, anything that include a plus operation on it, you're supposed to initialize the final result and the result as a 0. If you are calculating something that's including multiplications, you need to initialize a result, a final result with 1. Okay? So let's see, we'll do the tracing of this example. At the beginning, we starting with I equal 2. Why we started with I equal 2, not 0, not 1? Why do we starting with 2? We didn't start with a 0 or 1. Because the factorials of 1 it is going to be 1, while factorial of 0 is going to be 0. No, not because it's loop. Because the factorials of them is going to be 1. If you multiply the 1 with the 1, it is going to be 1. So it's not going to add anything to the result. It's not going to make any difference. So for this reason, we're starting from 2. So here, let's do the tracing together. So when I is equal to 2, when I is equal to 2, let's make the factorial is going to be how much? Before a loop, the factorial was equal to 1 before a loop. This is at the beginning. So now the factorial will be 1 multiplied by I, so it's going to be 2. Okay, then I, it is going to be 3. I don't have a problem with writing. Okay, then I is going to be 3. Is I is less than or equal to 5? Right. So then we will say the factorial is going to be 2 multiplied by I, so it's going to be 6. Later we're going to increase I, so it's going to be 4. Is 4 less than or equal to 5? True. So it's going to be 6 multiplied by 4. 24. Now we'll go back. We will have 5. Is 5 is less than or equal to 5? True. So we will have 5 here. Sorry. So we'll have 5. 5 multiplied by 24 is going to be 120. And then it's going to increase the I. It's going to be 6. Is 6 is less than or equal to n? It's false, so it's going to get out of from the loop. Then we will going to print it out till n, which is 5, and the factorial that we just count, which is 120. Sorry, I have some problem with the screenwriting here. Okay, sorry. Okay, so it's going to be 120. Now, let's see how we can do this with a recursive. You get the idea, so this is supposed to be easy for you guys. A recursive, the main 2 points, which is going to be easy, is the factorial of 0 is going to be 1 from the first functions. The other cases, in all other cases, the factorial n is going to be n multiplied by n minus 1. So if we write it as a function, it is going to be the first 2 sentences here. So let's see it here. We have the factorial function, so this is the factorial function, it is going to get one argument, which is its size, n. If n equal 0, which is the base cases, the simplest one, we're going to return 1. Otherwise, we get to return n multiple by the function is going to call itself, but this time we're going to reduce the size by 1. So first we will have 5. So it is 5 equal 0? No. So it's going to go with return 5 multiple by, and it's going to call the function again. We will have 4, as n is going to be 4 now. As 4 equal 0 now, it is going to call itself, and so on. So at the end, we will have 4 now, and then it's going to call 3 and 2 until we reach 0, which is going to return 1. Inside the main method, which is to test our idea, here we will get from the user. That's why we're using the scanner, n. So we're using next end, which is a reading integer from the user, and then we're going to print it out. We will call the factorial function sending n, then the positive number the user entered at the main method. Okay. So let's see how the factorials happen with this nice animations. So you're having a factorial of 5. Let's assume you send the n as a 4. If you are the user, you're putting n equal to 4. So we're having a factorial of 4 is going to be 4 multiplied by factorial of 3, which is main multiplied by 3 multiplied by factorial of 2. The factorial of 2 means 2 multiplied by factorial of 1. The factorial of 1 means 1 multiplied by factorial of 0. And then we're going to have 1 multiplied by 1. We will back. Now the idea, we will get back 1 by 1 to calculating the result. So 1 multiplied by 2, then 2 multiplied by 3, 3 multiplied by 4, so it's going to be 24. So the factorial of 4 at the end is going to be 24. Here they get to show us the same idea, another nice animation. And here they said we're going to use a data structure concept, which is LISTOC. We will talk about it tomorrow. Let's know what's a LISTOC in general, or in a simple way. So LISTOC, like when you're having a box and you put the staff one on top of each other. If you put some staff on top of each other inside a box, you cannot get the one at the end until you get the one on the top. So this is the idea of a stock. If you're putting any information or data inside the stock, you cannot get the one at the end first. You have to get the one on the top and then get the one next to it. So first come, last serve. أول واحد يدخل هو آخر واحد راح يخرج. الفكرة of a stock, first come. If you come first, you will serve last. So this is the idea of the stock. So this is how we can apply a recursive function idea. So first we call a main method. So it is going to stay at the beginning. Then we will call the factorial function for the 4. Then we will call it for the 3. So it's going to return the 4 multiplied by the 3. So this is the step 2 or step 1, because step 0, the initialized, we call it as a 0. Then we have the space requirement for factorial 2. Then we will have it for factorial 1. Then we will have it for factorial 0. Now if I would like to get the data out from this stock, I have to start from the one on the top here. I cannot get to get anything from down. So I have to start from here until reach the main methods to get a result. So the execution of return factorial 0 is going to give us 0. So now we will get back, okay? So we will return. So the factorial of 0 is going to give us return 1. We will back, it's return 1. So we will get this out. Then, you see, we don't have the factorial of 0 anymore inside the stock. Then step 6, it is going to return factorial 1, is going to return 1. The factorial 2, when we remove it from the stack, it is give us 2. Factorial 3, when we remove it from the stock here, you see you don't having 2. When we back to 3, we're getting 6. Why? Because you see here, this is going to be 1 multiplied by 1. Here is going to be 1 multiplied by 2. 2 multiplied by 3 is going to give us 6. So this is the return from this one. 6 multiplied by 4, this return is going to return to factorial 4, 24. Right? And at the end, the result of this factorial, this is already on the main methods that invoked the factorial data. They put it again here as step by step. That's exactly what we saw on the animation. Another example, let's assume we would not like to calculate the factorial. We would like to calculate something else has an addition operations on it. So let's assume you having a function when a 0 is going to be equal to 0. Okay, and when it's otherwise, it's going to be n plus n minus 1. I need your help figuring out what we're supposed to put behind those boxes. So first, this is the function. This is the recursive functions that's going to call itself to have the output of this. So we having L5, it is going to call F L4, LF for L4 is going to be F L4 plus LFN and so on. So first, what are we supposed to have behind the box here? What's the condition of F? This is the simplest cases. And what's the return of it? If what? Okay. Good. Good answer. So if n equal 0, it is going to return what? So this is the base cases. So this, it is going to cover F here. It is going to return 0. They give you already the answer. Okay, so what are we going to do for else? What we going to return for else? What are we going to return for else? Yes, we're going to have an n plus f for an n minus 1. Why is that? Because it's already like they already told us here, we're going to have an n as it is, but then the function is going to call itself, but this time it's going to reduce the size by 1. So this is the output of it. So we're having 5 plus L4 plus L3 plus L2 plus L1 with every time calling the same function minus Ln. And this is the result of the sum, which is 15. Okay. Now we'll talk about a problem called Fibonacci. Fibonacci numbers is a series starting by 0 and 1. Okay. So starting by 0 or 1, this is the series. Those are the indices. What we are care about is series now, how you can generate those series by knowing the indices. So if I told you what's the Fibonacci number within indices 9, what's the Fibonacci number when you have an indices as 9? Yes, so it's 34. Good? So this is the idea of it. You give me, or the user give you, what's the indices, and you return what's the Fibonacci associated number. First, you need to know Fibonacci for 0 is going to be 0. Fibonacci, those are no, Abdul Minam, is not an array. So this is, we are not going to store indices at all here. Okay, we're just going to get a number. We are not going to create those array, as you call it here. We are not going to create all these numbers. We will see now how by just telling indices, you can repeat the number, return the number, sorry. So the special cases here, we having 0 and 1. Okay. So we having 0 and 1. 0 is gonna tell Fibonacci. Fibonacci for 0 is gonna to be 0, and for 1 is a 1. Starting from 2, it is gonna to be different. Okay. So Fibonacci for any other indices is going to be Fibonacci for indices minus 1 plus Fibonacci for indices minus 2. So 1 step back and 2 step back. This is going to happen for any indices bigger than or equal to. So if I give you Fibonacci of 3, what's the 3 here? The 3 is the indices. So if I ask you what's the Fibonacci number when I have an indices as a 3, it's going to be 2. So let's see how we can calculate this. You see Fibonacci of 3, it is going to be Fibonacci of 2 plus Fib for 1. I make it as a color, so it's going to easy for you to trace it, guys. So Fib 2, it is going to call itself again as a Fib of 1 and a Fib of 0. F Fib of 1, it is going to, it's not going to call itself. Why? Because it's a simple cases, and it's already, we know it is 1. So the Fib of 1 is going to be 1. The Fib of 0 is going to be 0. Plus the Fib of 1, which is we already had it at the beginning. So we're having 1 plus 0 is going to be 1. The Fib of 1 is already be 1. So 1 plus 1 is going to give us 2. So at index 3, so 3 here is index. As index 3, the Fibonacci number is 2. Okay? So let's see the code. Here they give us 2 ways to solve the Fibonacci series. One is using a recursive, and the other, which is the below box, is using an iteration. So I would like you to focus now on the second box, which is the below one, using an iteration. We will trace it to see a result, and then we will see how we can do it with a recursive. So first, we will get till n. What's till n represent to here? Who can remember? What's till n? Is the n is the indices or the Fibonacci number? The n represents to what? Represent what? The indices or Fibonacci number? Any other thoughts? So one said indices, one said Fibonacci number. What cell N represents here? Okay, another ideas. Anyone else? Okay. What about the rest? What about the rest, guys? Okay. So good. Most of you get the right answer. So indices, N represents indices. So if you said at index 3, what's the Fibonacci number? This is the purpose of the function. At index 9, what's the Fibonacci number? So if they told us, for example, here, what's the Fibonacci number for, let's say, let's say we're having N as a 6. Then how we can do this tracing? At the beginning, I equal to 0. Result is equal to 1. The previous result is going to be 0. So this is before a loop. We don't have any value for temp yet. Okay, now we will enter a loop. So here we will start a loop. Is I, which is 0, less than or equal n minus 5? N is 6. N minus 5 is how much? 5. So N, we have it as 6. N minus 1 is going to be 5. From the beginning, we're going to know I is going to be 0, 1, 2, 3, and 4. Why not 5? Because they didn't said equal to. They just said less than. Okay? So first, so this is just for us to know which number is going to get, I is going to get which numbers. So at the beginning, we defined the temp. It is going to be equal to results. So it's going to be 1. A result is going to be equal to result plus the brief result, so it is going to be 1, because 1 plus 0 is 1. The brief result is going to equal to temp, so it's going to be 1. Now we will have I plus plus. This is when I was 0. Now I is going to be plus plus. Okay? When I plus plus is 1, 1 is less than 4, right? So temp is going to be equal to result, so it's going to be 1. A result plus previous, so it's going to be 2. And then the brief result is going to be equal to temp, so it's going to be 1. I plus plus, so I is going to be 2. Is it 2 less than 5? Yes. So temp is going to be 2. Okay? And then a result is going to be a result plus the brief result, so it's going to be 3. And the brief result is going to equal to temp, so it's going to be 2. Now I plus plus 3. Is the 3 is less than 5? Yes. So temp here, temp is going to be equal to result, so it's going to be 3. A result is going to be result plus the brief result, so it's going to be 5. The brief result is going to equal to temp, so it's going to be 3. I plus plus, so we're having it as 4. Now, a temp is going to be equal to result, which is 5. A result is going to be a result, which is 5 plus the 3, so it's going to be 8. And the brief result is going to be equal to temp, so it's going to be 5. I is going to be 5. Is the 5 less than the 5? No, so we are not going to get inside the loop anymore. So what's the result here? How much is the result that we're going to return? So what the Fibonacci number associated with indices 6 is 8. You're right, guys. Let's take a look to the answer here. Is our answer right? Yes. So we're having a Fibonacci number associated with a 6 is 8. Okay, what about using a recursive? How we can use a recursive? Let me clear that. A recursive, we having a function and it's going to get n. The base cases when n equal to 0 is going to return a 0. Also, if it's equal to 1, we're going to return 1. So those the cases that it's not going to call itself. If it's not 0 and it's not 1, then we're going to call the Fibonacci function 2 times. The first time we're going to send the n minus 1, so if we're having 6, here we're going to send the 5, and here we're going to send 4. Those is going to enter as n, and we will repeat those recursively. Let's see how we can see it in these pictures. So you see here the first step, or the 0 initialized step, is calling Fibonacci if we are looking for index 4. So it's going to be divided to 3 and 2. The 3 is going to call 2 and 1. The 2 is going to call 1 and 0. Then, so this is the 0 step. The second, or the 1 step, the first step, is calling Fib 3. It's not a 2. We're taking a look to the one on the left first. Then it's going to divide it to Fib 2 and Fib 1. We will call now Fib 2. We will leave this until we back. Then Fib 2 is going to make it Fib 1 and Fib 0. So this is the third step. Okay? We reach the end. Now it's return 1. So it's going to get the result back here with 1. Now it's going to take a look to the second part here. So this is the fifth step, Fibonacci of 0. So it's going to go to Fibonacci of 0 until it's reached at the end, which is returning, it's going to return 0 here. When it's done, you reach the end, it's going to return Fib into Fib 0. The seventh step is going to get those both return and return it into Fib 2 and so on and so forth. So you can trace it and see how it's worked with Fibonacci numbers using a recursive approach. Okay? Okay, so the idea behind the recursive is how we can use it to solve a problem. In the previous problems, we always have a return statement inside a function to call itself. But this is not always the case. We don't always have to have a return for a recursive. Sometimes you can do other stuff or operations to call itself again and again. It's not always a return. One of the example here, if they said you need to print a message n times, okay? You can either make it when you reach 1, it's going to print a message 1 time, and the other part is going to be n minus 1. Or the second problem, which is we're going to see it here, this is going to solve this part here, okay? Having the printing created in small sizes, where the base cases is going to be n equal 0, which is mean it is gonna to print this, unless it is it's gonna to print this as long as it's bigger than a 0, which is mean it's bigger than or equal 1. Okay, so let's see the function and how it works. Let's assume you're having this statement inside the main method, and you said I would like to print welcome 5 times. Okay, so here is the message. This is the first argument as a string. The second argument is times, which is the number of times you would like to print this message on. So as long as a time is bigger than or equal to 1, print the message. And also you see both of them inside the F. And recursively call a function again, but this time decrease a number of times because we already printed once. صح؟ احنا already طبعناها, we already printed once. So now we're going to decrease it once. And then it's going to happen again. It's going to, now times is 4. Is it 4 is bigger than or equal to 1? Is right, it's going to do this. What makes this different than the previous one? We see we don't have a return, and we don't have the base cases or the smallest هي اللي راح is going to stop it. We have only one if statement. So instead of having if else, you can create it only if statements. It's depending on the question. Okay. Generally, this is not the ideally way to print the statement 5 times. We can just using a loop, for example. We will see at the end of this lecture, a recursive is going to take a memory and time more than an iteratives. Okay. We will see now, it's okay, Asil. Okay, we will see now another idea of using a recursive, which is the palindrome. What it is? What does that mean? If they give you a string, let's assume this is the string. Okay, so let's assume we're having this string. Okay, and you would like to know if it's a palindrome. What does that mean? يعني إن هما متناظرة. إيش يعني متناظرة? That means if you divide it, the first letter here, it is equal to the last one here. The second letter, it is the same as the one, not at the end minus 1. And the third here is equal to the one at the end minus 3. Okay? So we'll see how we can do this. This example has little typo mistake. This is not supposed to be M capital. This has to be M small. Because if it's M capital, this is mean it's not a palindrome. Okay? So let's see how we can solve this problem. We're going to send a string S. Okay? We need to know when we're going to stop. We're going to stop if the length, الطول اللي حق الstring is less than or equal to 1. So if you have only one letter, that means you cannot compare 2 letters. What we're going to do, the idea, we're going to compare the first one with the last one, the second one with the one before the last one. So if you have only one letter, there is no way, you don't need to compare it with anything. So you at least need 2 letters to compare them together. So if you're having only one, it's going to return a true. If it's reached this point, that means it's already palindrome. So let's take this as an example. LM, LKK, LM. Okay. So length is 1 2 3 4 5 6 الطول حقها 6. okay, so is 6 less than or equal 1? No, so it's going to go to else if. Is that chart at 0, what do we have? M. Okay, I don't know what's the problem with this today. Okay, so we having here M, and then is that chart at S length minus 1. This is supposed to be what? What is this part at the first when we having this string, and now we are first time getting to else f. So we having the chart at 0 is going to be M. Which chart we going to get when we having the length minus 1? Which chart? M. Okay. Which chart is not a number? Okay, yes, the last one. So, are they equal or not? Are we going to give to else if or else? Are we going to go? Are they equal or not? So, are we going to get if else or else? They're equal, but what the else if said, if they are not equal. Right? So we're going to go because they are equal. They said if they are not equal, that means it's not a planogram. If they are not equal, we're going to go, we're going to enter to this statement, but they're equal, so we're going to go to return. And in this time, we're going to send a substring, so we will get a substring from this, but what we're going to get, we're not going to get from 0. We're going to get from L1, so we get L, K, and K, and when we're going to stop until length minus 1. So we get those 4 letters. It's going to get back here as a string, and we will repeat it until we reach length. So we will see those examples in the first line are planogram. However, the examples on the second line are not planogram. Okay? Any question? Any questions so far? Okay, Bushra. Repeat what? last else. Okay. طيب الآن احنا عندنا الكلمة اللي هي الام LKK الام. تمام بشرة؟ بالchar at 0 we will get M. والS that char at S length, which is this part here, we're going to get M as well, right? M is equal to M or not? They're equal. So هذا الشرط الS ما راح يتحقق. هي متى راح تتحقق هذا الشرط؟ If they are not equal. Okay, I think this is what's getting you confused here. هنا you're going to get inside the else if they are not equal, but in our case they are equal. So that's why we get to else. When we get to else, since it's equal, we make sure this is equal to that one. Now we need to check the next one on each of them. So that's why we will get from the index 1 until the end. Okay, and then we will repeat it again. Okay, it is clear now, Bushra? Okay, you're welcome. طيب, another example to use a recursive اللي we already mentioned it at the beginning of the class اللي هي directory. But in this time we don't need to just reach a directory or reach a file until the end. You would like to calculate the size. How we can do this? or calculate the sum of the size of all file on the directory. So if you're having a directory, you don't always having a file. You may reach a subdirectory, and that subdirectory may have a subdirectory, and so on. Okay. So the idea, you do recursively. البيزلاين here في هذا المثال is what? Who can figure it out? الآن حنا we would like to calculate الفايل size, حجم الملفات. If we reach الفايل, we're going to get the size. If we reach, it's not a file, it's a subdirectory, we will keep doing and calling it recursively. So when it's going to stop? What's the simplest case? What's the simplest case? Anyone? No? Okay, so we're going to stop when we reach a file. So the end of a file, we're going to get its size. But when we have a directly or subdirectly, in this case, we will keep going on. Okay? So let's see how we can do it here. So you're having a size. This is the total size of this directory. Okay. It is supposed to be having the size of the file 1, the size of the file 2, size of the file until the file M. And also a size of the directory. But in this case, the size of directory, we cannot get it straightforward. We have to call a function again to get all the files inside it. So this is how we use a recursive. Let's see the code to solve this problem. Okay. We will see some new methods that we didn't saw it before from the file class, but they are clear. Okay, so hopefully you get it right away. So first, we create function or method called getSize. And what's the argument of this getSize? What's the type of that argument? It's file. The type is file. And we will send a variable file. First, we're going to initialize sum. You remember, I told you, if you're going to calculate sum, the average, you initialize a result with a 0. If you're calculating something have multiplication operation, you will initialize it with a 1. Okay, so if a file is a directory, so is a directory is a method from which class? Is directory is a method coming from which class? Yes, it's coming from a file. Okay, so it's going to return. If I ask you what is this methods do, it is going to return true if it has a directory and false if it doesn't, if it's not a directory. So at the beginning, if it's, let's assume it's not a directory. Sorry, it's a directory. That means it has a file. So we're going to get inside this LF. Now we need to create an array with a type file. This array is going to include all the files inside that directory. So we'll go to this file, which is its type is a directory. So the file now is a directory. directory. So we're gonna to get a list of file inside it and store it here on the files variable. Okay, but we are not sure if it's all the file inside that directory are files or maybe a sub files also. Okay, so we'll see how we can deal with this issue. Now we will go over those lists, the array of files, one by one, starting from 0 until when? Until the file data length and it's not null. So it still have some file inside it. We're gonna to calculate the size is gonna to be plus get size إلى الفile 0 sorry. So at the beginning it's gonna to be 0. So we will go to the first one. Let's assume this directory, we have one directory. The first file on it is file. Okay, so it's gonna to repeat again and it's gonna to go to if statement. It's gonna to ask, is this file is a directory? It said no, because I said it's just a file, it's not a directory, so it's gonna to add it to the size. Are we done? No, we will back again to this loop. Okay, so when we get to 0, we assume we get a file. So it's back, it's called get size again, which is this get size here. And we will go to if it's false, and it's gonna to go to else because it's false, so it's gonna to add this file size into size. Now we will back to the loop again. I is gonna to be plus plus. So I is gonna to be 1 now. Let's assume we're having now a file again. It's not a directory. It is gonna to go to get size. And it's gonna to go to F. It's not gonna to go inside F because it's not a directory. So it's gonna to add it, calculate that file with the size again. Now it's gonna to return a size, it's gonna to get back here again. Now I is gonna to be 2. Let's assume we're having 2, it has a directory. It is gonna to enter to get size, go to the if statement. Inside the if statement is a directory, it's repeat the same process again and again. Okay? Now we will see an example called, or a problem called tower honey. What's the idea of this problem? Yes, Isam. This is the third case. إذا ركزت بالمثال اللي I just said it, Isam. I said in the first case في المكان الزيرو كان file. في الone it's file, so it's gonna to go to else. بالحالة الثالثة at index 2 it was a directory, so it's gonna to call itself again. But in this time it's not gonna to go to else. راح يدخل مرة ثانية بالif and it's gonna to do a recursive operation again and again until reach the file. Is that clear? يعني بالمثال هنا let's assume get الفايل لما جاء إلى get الفايل it is gonna to come here and test it if it's file or directory. راح يدخل إلى كل فايل دخلناه بالarray يخص هذا الدايركتري and it's gonna to examine it. If it's a directory, it's gonna to do all these steps again for it. Else, if it's not, it's gonna to just get the size. I don't know, Isam, if it's clear or should I repeat it again? Are you sure? Okay, good. I think you can try to trace it by hand. Maybe let's make it even more clear. Okay, you're welcome. Okay, خلينا نشوف الآن. Let's move to tower of honey example. إيش هي الفكرة حقها؟ The problem involves moving a special number of disks of distance size from one tower to another while observing the following rules. يعني يكون عندنا two towers راح ننقل الديسك from one to another but with a certain rules. The first rule, we're going to have n disk. عدد disk is going to be n, and they having a label 1 2 3 until n, and a 3 towers. For example راح يكون عندنا 3 towers, ال A will B will C. This is the first rule. The second rule, no disk can be on top of a smaller disk. يعني أبداً ما راح يكون في disk أكبر من الديسك ويكون فوقه. So always the smaller is going to be at the top. Okay. All the disks are initially placed on tower A. So at the beginning كل الديسك راح يكونوا بالtower A. Only one disk can be moved at a time, and it must be top disk on the tower. يعني حنا نقدر ننقل. We can move only one disk at a time. If you don't get it, don't worry. We will see the example here, or the figures is going to make it clear for you guys. Okay. So the objectives for this problem is to move all the disk from A to B. الهدف النهائي, if you see here, we start from having the disk at A. Okay, we having it at A, and at the last step, we having all the disk at B, with considering a rule and the bigger is going to be at the bottoms. But we'll never ever having a bigger disk on the top of a smaller one. Okay, so let's see how that works. First, this is the original position. They said all the disk is going to start at A. Good. Then we move the first one, we put it to B. So far so good. Then we would like to move it 2. But if we move it 2, on the top of the B, on the disk 1, this is going to violate the first condition. They said no disk can be on top of a smaller. الآن ال 1 is smaller than 2, so we cannot put 2 on top of the 1. So for this reason, we will get assistance from tower C. يعني tower C راح يساعدنا أساس إن إحنا نكمل العملية. So it's going to save 2 now. Now what we're going to do? We would like to move the 3. The 3 we cannot move it either on top of 1 because the 3 is bigger than 1. إحنا ما نقدر نحطه فوق ال 1. Also we cannot move it on top of 2. So for this reason we're going to move the 1 on top of 2, and this is acceptable because the 1 is smaller than 2. And we will move the 3 on we will move the disk 3 into the B. Okay, now we would like to move 2 and 1 into B. We can move, now we having the 1. We can move the 1 on top of the B. But then how we can move 2 on top of the 1? It's not acceptable. So for this reason, we will move it into A. 1, we will move the disk A 1 into A just to get the 2 from C, and then move it into B on top of disk 3. Almost there. So the 1 is left now as 1, which is on tower A, and now we can move it on top of B. So this is the idea of tower Hanoi. Okay. Now we need to see how we can divide it into small problems. So the tower A is going to be n minus 1. We're starting with tower A, and we will end up with having the same disk on B. So if you see here, this is the first step and this is the last one, which is 0 and 3. And number 1 here are, number 1 and 2 and 3 and here. So those represent number 1 on the previous example. And also those steps from 4 until 6, they represent a second step. So this is the first, this is the second, this is the third, and this is the fourth here. Okay? Let's see how we can do it using a recursive approach. But one thing to be considered in this example, if you remember in the previous one what they said, move it from A to B with the assistance of C. In this example, we have it move it from A to C with the assistance of tower B. Okay. Then said move a disk N from A to B. Move N-1 from C to B with the assistance of tower A. Let's see the example, or let's see the code, how we can do it. This is the main method. It doesn't have any special things. It's just going to invoke a method, which is move a disk. We're just going to get from the user a number of disks. We print them out. This is the main thing we are care about, is invoking the move disk. So let's see how this is work. How many arguments and move disk gets? 4 arguments. N, A, B, C. What's the type of N? And what does it represent? What the type of N and what does it represent? We haven't entered any number now. I see it. Okay, so it's integers. It's representing what? A number of disks. Good. What about A will be with C? What's the type of A will be with C? Good. And they represent what? The first one is going to represent from what? The second one represent going to which tower? To which tower? And the third one represents the helper or assistant tower. طيب. At the beginning, let's assume the user, we having a number of disks 3. We having 3 disks. Starting as we having in the example. Sorry. So we're starting at A, B, and then C. If N equal 1, that means this is the last step. It's okay, Asin, I already told you. طيب. So this is the last step. What is going to happen at that step? We just going to print out. It is going to be from which tower to which tower. This is the last step, the base one. The whole work is going to be where? At else. And else it is going to do 2 things. it is going to call move disk 2 times. Okay, so it's going to recursively call it. When all the call is done, it's going to print out and it's going to call it again. Let's see how we can do the tracing here. And I put the code for you to remember what we're going to do it. And sorry if it's quite small, but this is the best way to trace the code while we're seeing the example here. So let's start at the beginning. We're having A as N, starting from A to B with the help of C. And when we go to F, it is going to be false, so it's going to enter else. When it goes to else, it's going to invoke move disk 2 times. The first time it's going to send N-1. So let's assume this is the first time. Let me choose another highlighter. So this is the first time here. So it's going to be N-1, which is 2. And in this time, we will keep it from 2 similar. So it's going to be A. But 2T, it is going to be different. We will using C, you see here, this is going to get what you already having at C, at the assistant tower. The assistant tower now will be a 2T tower, okay? And B, which was the 2 tower, it is going to be the assistant tower in this time. Okay? Now we will go at this step. We are not going to do the printing or calling the other things. So this is step 1. It is going to go here. Okay? So let's erase this. Then the second step, we're going to send what is going to enter to the code. It is going to enter that one, which is 2A, C, B. It is going to go in F. Is N, which is 2, is bigger than, equal to 1, it's false. So it's going to go to else. And at this time, N is going to be 2 minus 1, so it's going to be 1. And what we're going to have for the front tower is going to stay as it is, A. The front tower is going to stay as it is, A. Now we're going to change. A 2 tower, it is going to get الchar اللي موجودة as assistant. What do we have for assistant? B. So now it's going to become a 2 tower. Okay? And the assistant tower, it is going to be the opposite, a 2 tower. Are we done? No. This step is we'll call this recursively. Okay? So let me change the highlighter. Now, we are here. What are we going to send? We're having N as 1. And the from 2 is A, the 2 tower B, with assistance C. We'll go to the if statement. Is N equal 1? True. So now, we will do this. We'll print this sentence out. We'll say move disk 1 from A to B. When we're done with this step, Now we will back to this print. We're going to print now. We're done with this, right? So now we will print move a disk 2 from A to C. And now it is going to go to the second sentence here, which is, oh, this is so dark. Okay, so now we're going to go to this sentence. Okay, so it's going to send the A, B, C, A. We're going to go to this sentence here and move this. We're having n minus 1, which is 2 here, right? So it's going to be 1. And it's going to change from 2 into assistant. So assistant here, it will become from 2. And 2 tower is going to stay added as, and an assistant tower will become the from tower. Okay, now we get to call invoked methods again, invoked itself by sending 1 BCA. It is going to go to F. Is n equal 1? True. So it's going to print this sentence out here. And when it's done, we're done with all these blocks. When you print this sentence out, we're done with all this blocks. So we will get back here. We're going to print this, and so on and so forth. Okay? I know it's quite have a many sub-steps, especially for recursive. But I can answer you if you have any question now, or you can trace it and let me know if you don't get how you do it. But let me see now. If anyone has any question about Hanoi tower? Any question? Okay. So now we will move to, let's say, more directed example, which is the GCD. What's the GCD mean? Does anyone know what's the GCD mean? What's the GCD? Do you know what's the GCD? The answer is already on the slide. The greatest what, Bushra? The answer is already on the slide, guys. The greatest common dividers. What does that mean? So if I say, what's this GCD of 2, 3, I ask myself, what's the number 2 can be divided into 2 and 1, right? The 3 can be divided on 3 and 1. So what is the biggest or the greatest common divider? القاسم المشترك الأكبر صحيح يا بشرى؟ راح يكون ال1. In the other example, if I having a 2 has can divide by 1 or 2. A 10 can divide it by 1, by 2, by 5. But the common dividers, we cannot choose the 5 لأن احنا نحتاج the common dividers, so it's going to be 2. So how can we solve this problem? There is 3 approaches to do it. The first approach is using, so the first approach is using the brute force approach. What is this approach going to do? It's going to start with the minimum of the 2 number until 1. يعني مثلا, for example, if we trying to calculate the GCD for 2535. So what's the minimum for 2535? What's the minimum? Between the 25 to 35. المينيموم يعني أي رقم فيهم هو الأصغر. Between them, among them. The 25. Thank you. So if we're using المينيموم method, return الرقم الأصغر. فالمينيموم between 25 و 35 is gonna to return 25, right? So you're gonna to go from 25 until 1 to check if there is a common divider between both numbers or not. هل هي فكرة first approach. الother approach هي equalist algorithms, والأخيرة هي recursive اللي هي نفس what we are talking about. So let's see how equals algorithms work. We will have two numbers, which is الM والN. تمام? We will get the absolute value, القيمة المطلقة إلى الM, and we will see that at T1, والabsolute إلى الN اللي هي القيمة المطلقة إلى الN, we will see that at T1. We will calculate a remainder الباقي when you're dividing T1 by T2. As long as a remainder لا يساوي 0, we will switch them up with a remainder and we will calculate a remainder again. خلينا ناخذ example. مثلا لو كان عندنا 10 I have problem with the pen here. Okay. So let's assume we having 10 and 2. Is there any difference لما نوجد GCD لما يكون عندنا T 10 2 or 2 10? We supposed to get the same results. لكن the process is going to be different. خلينا نشوف كيف the process is going to be different. خليني أمسح هذه. So let's start with having when we having 2 and 10. Okay? T1 it's going to be الابسولوت اللي يحق الام, so it's going to be 2. with T2 الابسولوت اللي يحق الان is going to be 10, right? الآن الريمايندر لما يكون عندنا 2 remainder by 10 is going to be how much? A reminder 2 a remainder by 10. No, it's not 10. لما يكون عندك 2 books and you have 10 people, how you can divide those two books to give it to 10 people? So you cannot. So that's mean, yes, Bushra, a reminder is going to be 2. A reminder is going to be 2. Now we will go to while. Is it 2 is not equal to 0? Yes. So T1 is going to be equal to T2. So what we have in T1 here is 10. And a T2 is going to be equal to a reminder, so it's going to be 2. And a reminder is going to be a reminder now of 1, which is a 10. Reminder by a T2, which is a 2. Now it's different. A 10 reminder by 2. It's count how much? When we have 10 and then reminder 2. You have 10 books and you would like to give it to 2 peoples. Can you give all of them the books or is going to be any reminder? No, we are not going to have any reminder. So a reminder is going to be 0. Okay? Now we will back to while loop. Is a reminder not equal to 0, false. So we're done with the loop. So now what's the result? Is it T2? Where's the T2 here? So the GCD between 2 and 10 is going to be 2. Okay? You can try it when we have it opposite. When we're having M as a 10, test it at home. When you're having M at 10 and we're having N as 2. It's going to be easier than having it 2 to 10, but you will get the same result. Okay? The important part for us is how we doing it in a recursive method. So, if you're having a GCD إلى الM والN, it's going to equal الN. متى راح تكون تساوي الN؟ لما يكون الريمايندر 0. Like for example, if you're having a 10, remainder مع 2 is going to be how much? 0. So the greatest common divisor is going to be 2. Okay? So this is the base cases here. The GCD for the M والN is going to be the N. If the M remainder, the N is going to be 0. Otherwise, we're going to call GCD again. It's going to call itself, sending the N as it is, but the second argument is going to be the M. It is going to be the M model N. So first, we will get two arguments, the M and the N. Okay, so we'll get the M and the N. If the model doesn't equal 0, if it's equal 0, we will return it 2, as in our example. When we have a 10, model 2 is going to be 0, so we'll return it 2. Otherwise, we will call it again, we will keep the N as it is, and we will get the model of the M, model N. So let's try to get the same example. We saw it before. We had it before, sorry. What we did here, a 2 with 10, right? So we having a 2 and we having a 10. When we get at the beginning here, a 2 model N equal 0. When we said 2 model 10 is going to be 2. So that means we are not going to go F, we're going to go to else. Okay? Now, when we go to else, we're going to do it again. M, it is going to be equal to what we have at N here, which is going to be 10 now. And the N is going to be the model. The model is 2. So we're going to send it as it's N. Now, a 10 model 2 is going to be 0. So here we will go. Is a 10 model 2 0? True. So we will go to the if statement. So now we will return a 2 in this example, which is N here. Okay? Do you remember الاتش التي اتش التري عملناها اللي شفناها بالسلايد اللي في البداية? So we having a tree with edge, which is calling recursively to draw the edge. So now we'll see something similar to it called fractals. What's the fractals? هي عبارة عن geometrical figures. But الفكرة منها إن you can divide it into a part. كل جزء منها each of which is reduced size a copy of the whole. يعني الجزء البسيط منها عبارة عن مصغر إلى الرسمة كلها الكبيرة. فهي كل جزء صغير عبارة عن نفس الصورة للصورة المكبرة ولكنها بشكل أصغر. Okay. There is many interesting example in this section. راح نعمل introduce إلى only one of it, which is اللي هي السيربن سكاي triangle اللي راح نشوفها هنا. كيف راح نرسم هذه السيربن سكاي triangle؟ So at the beginning راح نبدأ مع مثلث متساوي الأضلاع equilateral triangle, which is considered to be the factorial of order. إيش يعني ال factorial of order؟ اللي هي level 0 اللي راح نبدأ فيها. Okay. اللي هي هذه خلينا نسميهم figure A, B, and then C and D. Okay, تمام. Okay, so then what we have to do? So we are at stage 1, 0, which is we having equilateral triangle. This is stage 0. Stage 1, which is B, connects the midpoint of a side of a triangle of the order 0 to create a serpent sky triangle of the order 1. كيف راح نعملها هذه؟ We will decide with I said midpoint of the side, يعني المتوسط إلى كل ضلع. So here, this is the midpoint. Then what we're going to do? We're going to draw, we design or we define a midpoint, and then we're going to draw a triangle. This part, we're done with it. Okay, so now we're done with this one. Any triangle, you draw it, you're done with it. You're not going to touch it again. The second step, الآن we're going to move to C. Leave the central triangle intact. So حنا فقط راح نتعامل مع التراينجلز اللي تكونوا، مش مع التراينجل the one that we just draw it, the green one. Connect the midpoint of the side of the 3 other triangles. So we're having 3 other triangles, 1, 2, 3. Okay, and then we will repeat the same things. So here is the midpoint here, this is the midpoint, this is the midpoint, and this is the midpoint for this one, midpoint for this one, midpoint for this one, and that one as well here. So we're going to now draw those 3 triangles, and we are not going to touch them. Now we're going to move one level. We're going to repeat it again, doing the same things with a D here. So we will move here. This is the midpoint for this, the midpoint, and the midpoint, the midpoint. Sorry, it's not that. Constant midpoint here and midpoint on each of those. And we're going to create triangle on the white part, not on the one that we created. Okay? So this is the idea of a serpent sky triangle. This is going to show it in little more details. So we having the first triangle with the 3 points P1, P2, P3. When we call a function display triangles, we're going to send the order. So the order at the beginning it was 0, and then it's going to be 1. Okay, sorry, the order at the beginning you're going to tell how many times you're going to repeat it, so it's going to reduce it every time. So the first time it is going to starting decreasing. So we're going to call the same method for each part. So we're going to call display triangle for this part and that part and that part. But now we need to consider that we are changing the endpoint. So here we having the same head point, which is the B1, but the two other side is going to be different. The same thing with this. The bottom one on the right is going to be similar, but we're going to change the one on the top and the one on the left. Okay? The last things we're going to talk about. So why we do need recursions, and how is going to be different than the iterations? What's the advantage? What's the disadvantage? Recursions is an iterative from the program control and essential repetition without a loop. فاحنا راح نعمل تكرار, we're going to repeat but without using a loop. The idea, if you remember when I told you في الexample اللي عملنا فيه when we doing the print, a recursive is going to have overhead. Okay? It is going to have overhead بالإضافة إلى أن each time the program call a method, the system must assign space في الميثود. لeach variable موجودة. فعن نفس الميثود, let's assume you're creating 3 variables, 5 variables, 10 variables. Every time you call this method, you're supposed to reserve, راح تحجز مكان في الميموري for all local variables inside the method. So let's assume we're having a method that has 5 variables, and you call, and it's called itself 10 times. So it's going to reserve 50 spots في الميموري. Okay? So which is going to get a lot. And in addition, it's take a lot of times comparing مع loop. So if we're having a simple example, مثل what we saw is just printing, it doesn't work to using recursions. So ايش هي الادفانتج؟ we saw the disadvantage. الادفانتج for recursions is to solve a problem that's inherently recursive, مثل اللي شفناها المثال directory. Some example, like if you would like to calculate the size of a file when you're having a directory, it's not easy to do using a loop. Okay? So this is the end of our meeting. Thank you for your time, and let me know if you're having any question.